Hello and welcome to week 8. So this is the third of our 3 weeks that we're going to spend on loops. This is the week where things definitely start to get pretty complicated. Good news, bad news. Good news, I guess we're almost done with loops. Bad news, we're going to be moving on from them and into functions next week. I don't know where I'm going with that exactly, other than we've done loops for 3 weeks. We're going to keep doing loops like every week for the rest of the course. Once you get into loops, you never get away from loops. Loops are powerful. They're interesting. Much like ifs, we do ifs every day now. Just like variables, we do variables every day. All the coolest programs, most of the coolest programs generally have loops in them, so yes, this is the last week we're going to spend on loops, and I do know that things are going to get complicated this week. I'm just trying to tell you not to be too worried about it. It's not like your final exam is going to be a bunch of loops, lists, and dictionaries. I mean, there's definitely going to be loops on there, but there's going to be other more simple stuff as well. So the thing I want to make clear is the first thing that you should do is watch this. This is a thing of its own, right? This is a solution video to the loop assignment from last week. The loop assignment from last week was an excellent assignment. Excellent in that it's very much like a test-like questions. So if you did well on this loop assignment, or if you had a good grasp on it, then you're doing great. If this was pretty shaky for you, well, like I just said, watch this video. I always know that there's people who don't watch these videos, and I feel like the ones I'm talking to right now who need to watch this video are the ones who aren't going to watch this video, and that means they're not going to watch that video. But I'm telling you, this is here for you. I'm not going to give you a ton of feedback on this because I'm giving you this. So this is the first thing you should watch is this. I don't care how well this went for you. You should watch this just to see how I did it. There are different ways to solve problems, and that should be pretty clear right now, but this right here is meant to be in a pretty important part of the lecture. Well, now with that said, I'm going to go into this now, which is what I'm doing right now. So it's this thing, has a different name, but you'll see in a minute. So there's some data files as well. This lecture is going to have more stuff in it than most lectures. That being said, I will begin with the lecture. But I also want to repeat the thing I said a minute ago, which is really, before you get into this lecture, you should watch this. All right, so this week we're going to talk about lists, loops, and dictionaries. So another week on loops. The difference this week is that we're going to be talking about using for loops to iterate over lists. So like I said, the first thing you should do is watch that homework review. On that homework review, there were several good problems. One was a while loop, one was a for loop, one was a sum of numbers problem, one was a data validation problem, and one was a S-count problem. Each one of those is a different kind of loop. All of them very... I really like every one of those problems. I think it's fair for me to tell you that. Like data validation is a common thing, searching a string for a thing's common, adding up all the numbers is common, and knowing how to do a while loop and a for loop is helpful. A while loop is probably more versatile, but as you'll see, for loops are going to be our best friend when it comes to lists and dictionaries. So, reviewing, while loop flowchart. So basically, if we're going to create a while loop, we have to create a counter. Well, I mean, you could do like a sentinel loop, but oftentimes we have a counter. So, right, we start, declare a counter, evaluate a condition, execute statements, increment the counter, right, and we keep going through this cycle until we get out of the loop. So, presumably, the way, I mean, there's not a lot of detail here, but there's some counter, and at some point that counter reaches some criteria, and then we are out of the loop, right, when this condition evaluates to false. Right, it's just a while loop. This week, we're going to be using a lot of for loops. For loops are interesting because they don't, in a for loop, you don't need a counter, and you don't need temporary variables. That's kind of the selling point on for loops. And as you see, they're going to be very helpful. In the real world, you generally have a choice between while loops and for loops. My best cautionary information for you is that for loops are kind of cool. I get why people like them, but there are always people in a class like this that start trying to use for loops for everything, and for loops are not the best choice for everything. You could just use while loops, and your life would be fine. So do not force a for loop where you don't have one. All right, so now we're going to talk about, instead of a counter-based loop, or a sentinel-based loop, which is different, talk about iterating over a list. So a list is, well, we've talked about lists. Remember slicing lists? I also talked about how strings are lists, right? A string is a list of characters. A list is a variable that stores a bunch of things in it. Like a normal variable just has one thing in it. Maybe it's a number, maybe it's a string, maybe it's a Boolean. A list stores a bunch of things, right? So you might have a list full of numbers, or a list full of words, or a list full of students, or a list full of something. So you can use a while loop to iterate over a list. You can do that, but then you need to use this function called len. So len will tell you how long the list is. Now, the reason why lists are different than the other kind of things we've looked at so far is you generally don't know how long a list is. You'll just get some list from somewhere, and you'll be processing that list, whether you're printing it or searching it, or I don't know what you're doing, stuff. You'll see a bunch of examples this week, so I'm not too worried about trying to quantify that right now. But if you're going to use a while loop, you'll need to use this len property to figure out how many things are in it. You generally do not know how many things are in a list. For loops simplify iteration over a list greatly because you don't need a counter. You don't need to explicitly fetch the values. And we're making the assumption that you want to view everything in the structure. So it makes the housekeeping as simplified as possible. So here's a flow chart. So we're saying it's a for loop. And for, I mean for each is the term we use here in the world of Python. So have you reached the last item yet? No? Okay, do the thing. Have you reached the last item? No, do the thing. Have you reached the last item? No, do the thing. At the point where you've reached the last item, then we're out. So you see, there's no counter. It's not like start at 0 and go to something. It's just, we just give it this list, and we look at the list, and we say, hey, are we at the end? Nope, 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 until yes. And so you see, we don't know how big it is. We don't need a counter. That's what a for loop's for, or what we can use a for loop for with a list. All right, now if you wanted to use a while loop to iterate over a list, you'd need this len property. So I could give you a list with say it had 50 states in it. If you go len of that list, it would give you 50. And then we would initialize our counter to 0, and we'd say while counter, or while I is less than the length of the list, then just look at each thing and keep incrementing the counter. You could do that. Like I said, for loops are cool. For loops are going to be very useful for lists, but you could use a while loop. You certainly could. And I keep using this term iterate. Iterate means visit each thing in the list, basically. Right? So iterate over everything, get the current value, do something with the value, update the counter, then get the next thing. Look at it. Update the counter. You could do that, and I will do a bunch of examples. It feels weird to just sit here talking right now, but that is what I'm doing. All right, and so this is how it would work with a while loop. So you'd need to use this len property to figure out how long the thing is, or how many things are in it. If you want to use a for loop, it's this for in syntax. There's no counters, no incrementing. The value is easily referenced, and the code's shorter. You're going to love them, and I know that some of you are going to really get attached to for loops when you see how helpful they are for iterating over a list, but I will repeat for, the 5th time today already, for loops are not great. They're not wonderful for something other than a list. I mean, hey, you can use them if you like, but don't go thinking that smart people or good programmers use for loops all the time, because that's not true. What I do see a lot of is bad programmers trying to use for loops where they probably should be using a while loop. You have choices. As you will see, I'm sure you'll agree that when you're looking at a list, a for loop is going to be easier, but for just about everything else, I don't know. So this is me just showing you some code. So what we're going to do a lot of in this class is just creating a list of random numbers. And so this is just kind of the copy and paste little thing for it. So I'll show you. This process involves repetition of random numbers. This is the you should not copy and paste this. Copying and pasting is the worst way to learn about programming, but you're going to do import random. You've seen that before, right? We need that when we want the random library. And then this syntax right here means I'm creating something, it's named my list. You can call it whatever you want. And I'm assigning it to empty square brackets. That just means I'm saying that this thing is going to be a list. And then here's that for in syntax. So for I is the name of my counter, in range 0 to 20. My list dot append random dot randint 1 through 100. So this is going to create something called my list, and append means tack something. Like it starts off as an empty list. It means tack something onto the end of it, and that thing that you're tacking onto the end of it is a random integer between 1 and 100. So this is going to give you a list called my list, which consists of 20 random integers from 1 to 100. As you can imagine, there's a bunch of prompts I could ask you. I could say like, write a loop that creates a random list with 50 values from 20 to 60. Well, then there'd be a 50 there and a 20 there and a 60 there. It's kind of just substitution. This is going to be like the size of your loop. This is the lowest value, and that's the maximum value. I know it kind of looks bad, I think, but that's just what it looks like. This is the inside of the loop. That's how you create a random list, and we're going to do it a lot. So you might want to kind of jot that down or mentally notice something. Do something, because that's the cookie cutter process for creating a random list. So now we're going to talk about searching a structure, just a lot of flowchart kind of stuff. So searching a structure, or I'm going to say a structure, I mean like a list or a string, or you're searching a thing, right? It's a structure. It's one of the fundamental programming tasks. It involves repetition and a decision structure. So when you need to find something, you're just going to iterate over that thing. And by iterate, I mean look at each element in the structure and ask questions like, does something exist? Like, so for example, you might want to search a string and see if there's an S. You might want to search a list of random numbers and see if there's a 50 in there, or see if there's anything greater than 40, right? I don't know, some kind of criteria. This is going to be like an if. How many of something exists? That's like the S problem, right? Counting the S's in something. In both of this is iterate over it and look for something. This is iterate over something and count how many of something exist. Another very common problem is iterate over something and find the maximum or the minimum element in that thing. Right? So if you have a list of 1,000 numbers, what's the biggest thing in there? What's the smallest thing in there? Right? These are all search problems. You've got this big thing, you don't know what's in it, and you're trying to figure out, is there something in it? How many of something is in it? Or what's the biggest or smallest thing in it? Those are typical searching problems. Another common thing is sorting. We're not going to do sorting in this class, but sorting is another common thing to do to a collection or a list. Another term you're going to hear me use is array, which here's I was trying to find a flowchart for a search algorithm, and in most languages they call them arrays. In Python they call them lists. That's one of the things I don't like about Python. The one thing I like about Python the least is that Python tries to be different just to be different. But this idea being that different is just better. Most languages call what Python calls a list as an array. But, hey, we're calling them lists. All right, so in this flowchart, though, it uses the term array. You could just pretend it says list. So start, get the list. Is there anything left in the list? If there's not, well, we go to the end. Is there something left in the list? Yes. Search it. Did you find it? If not, go to, is there more stuff in the list? Search it. Did you find it? If not, is there more stuff in the list? You see, so at some point, you're going to say, no, there's not more stuff left in the list, and you'll say, search item not found, right? If you reach the end of the list and you never find the thing you're looking for, well, then it wasn't there. The other way you can get out of this list is right here. So you look at the next thing in the list. Did you find it? Yes, I found it. And then so you print out something about you found it. So you see there's two ways to get out of it. One is you found the thing you're looking for. The other is, you found the thing you're looking for. The other is you reach the end of the list. That's what the flowchart looks for, like for searching. And so now, well, in a minute here, I'll start doing a bunch of examples. At this point, you're probably like, oh gosh, I wish I could see some examples. Well, you're going to get examples. I'm not too worried about that. We're just sitting here, I'm trying to help build an understanding before you just start seeing me write code. And really copying down the code I write there's not a lot of value in that. Hopefully the things I'm talking about are making some sense. So if you want to find the maximum or the minimum, which is probably the most difficult thing that we'll do in this class, and we'll do it quite a few times, what you need to do is look at every item in the list. Right? If you're searching a list, there's no way to know what the max or the min is without looking at everything in it. So you want to compare each item in the list to the biggest value that you've ever seen. So like when you start off looking at a list, the first thing in it may or may not be the maximum. You don't know. So what you would do is you would take that first value and you'd assume that that's the maximum. And then you'd look at the second thing, and you'd compare the second thing to that thing that you already had as the maximum. If that new thing is bigger than the thing that you had before, then you'd make it the new max. If not, then you just look at the next item, right? So you look at the first thing, then the second thing, compare those two. And then you keep the larger of the two. Then you compare the larger of those two to the third thing. If the third thing's larger, then that's your new max. And then you look at the fourth thing. And if that's the largest thing, then that's your new max. And then you look at the fifth thing. And if the fifth thing is not larger than the biggest thing that you've seen so far, then you just move on. And at the end, at some point, you reach the end of the loop, or the end of the list, and whatever that thing is that was bigger than the greater of the two quantities, that thing ends up being your max. So that being said, I can only talk through it so much. here's the point where I should just do some examples. And so you'll see some examples of this. All right, so I've talked about as much as I can talk about loops. Now it's time to just start writing some loops. So there's a bunch of examples here throughout this lecture. So random numbers. So I'm going to create a list with 100 random numbers between 1 and 1,000. All right, this is that thing I said that you were going to do a lot of, this thing here. I'm going to do that. I know where it comes from, that's where it comes from. All right, so first thing I need to do is import random. All right, if I'm going to do random stuff, then I need to import random. Next thing I said I was going to do is make some variable. I'm going to call it my list. There's no reason to call it my list. You could call it the list. Or you can call it numbers. I don't care what you call it. You should call it what makes sense to you. It is a list full of random numbers. And then the cookie cutter way I was going to do this is I'm going to use a for loop. So I'll say for I in range. And this is for in range loop. Go from 0 to 100. I said I want 100 things, right? 100 random values. Okay. So that means we're going to run this loop 100 times. And then what I'm going to do is stuff 100 numbers in that thing called numbers. Whatever your list was called. So append is the function I'm going to use. I told you append is used to stuff something onto the back of a list. And I'm going to do random dot randint. And I want those values to be between what? 1 and 1,000. So 1, comma, 1,000. I need 2 parentheses there. That one closes that. That one closes that. Do you see how those are a little bit blue? That's called parenthesis matching. It's helpful. So this right here, that will, here's I import random. I created some list called numbers. This means I'm going to do 100 of them. Start from 0, go to 100. Exclusive of that top number. And then I'm going to append values between 0 and 1,000. So that right there does that. Now I'm going to use this list to print the values in the list. All right, so when I say print the values in the list, it means write a loop to print the values in the list. You could print them like as you were doing them, but I'm not going to do that. So I'll say for. Now here's a value. So it made sense to use I here because it was a counter. This is a normal, iterating over a list kind of thing. So you can call it like val or number, right? Because it's a list full of numbers. So I'll call it, I don't know, value in numbers. The only thing that's not negotiable is that. That needs to be the name of that list, right? So that is a keyword. That's a keyword. That's a symbol that you need. That's the name of the list. That is whatever you want to call it. And I'll say print value. Right? This is an excellent use of a for loop. This right here, no, not really. This you could have just done a while loop, and it wouldn't have been any problem. It would have been while I equals 0. Or sorry, it would be I equals 0. While I is less than 100, numbers.append, randint, one. Right? This right here could have been a for loop. I mean a while loop for sure. This is where a for loop actually pays off. So let's run this thing. It's going to be kind of weird. It's not really clear what it's doing, but it's doing something, right? Those values do look like they're between 1 and 1,000. And every time you do it, you're going to get different stuff. Right? I don't know. Does it work? Does it not work? I don't know. It seems like it works. It's a hard one to test. How many values are greater than 50? Right? So this is a search problem. I could do it in this loop, but I'm not going to. I'm going to write a different loop to do this. So I'll say for, every other language uses parentheses there, so that's a bad habit. Well, it's a good habit, but it doesn't work in Python. So I'll say for value in numbers. I could. It's just another for loop. Could call it value. Could call it val. Could call it num. I don't know what you want to call it. It's something. So I want to figure out how many of these things are greater than 50. Well, if you're going to count how many of something there are, that means you need a variable called an accumulator. So I'll say over 50. That's what my variable is called. And I'll initialize it to 0. And so I'll say if num is greater than 50, then num plus equals 1, right? So I add 1 to my accumulator. So my accumulator starts off at 0. Oh, sorry. I didn't do... That was totally wrong what I just wrote. It was over 50 plus equals 1. I don't even know how I did that so bad. Right, so every time I find a number that's greater than 50, I add 1 to that thing. And then at the end of my loop, notice how I delete away those indentations. I say print number of numbers over 50, colon, close my string, concatenate, string over 50, and extra closing parenthesis, and that'll tell me how many of the numbers are over 50. So it says there's 95 over 50. Is that believable? It seems about right, because the range is between 1 and 1,000, so on average there should be like 95 of them. So I'm getting values that, see, this seems about right. So I did one loop to create the random list, one loop to print everything, another loop to count all the things that are over 50, right? This is my conditional statement right here. What's the maximum value? All right, so this is one I talked about before, so I'll do another for loop for this. For, just to be weird, x in numbers. I mean, x is a pretty bad variable name, but do you really think num is descriptive? Do you really think value is descriptive? I mean, x is not descriptive, but it's a thing in an array, in a list. I don't know what to call it. So, if you want to do a min or a max problem, what you need to do, always the same process. So before you iterate over it, you should make a variable called max. And what do we want to initialize it to? I'm telling you, you don't want to initialize it to 0. Because what if this list was just full of negative numbers? Well, then you'd end up saying 0 is the max, which it's not. So there's only one logical thing to initialize max to, and that is the first thing in the list, which is the thing in spot 0. So initialize max to the first thing in the list. And now we're going to iterate over the list, and we're going to do some comparisons. So I'll say if x is greater than max, right? So if the first thing in the list is greater than the max, then the max is equal to x. Otherwise, nothing. And then we go to the second thing. Is the second thing greater than the max? If it is, we switch them. Then we look at the third thing. Is the third thing bigger than the max? If it is, then we switch it. Notice that if it's not bigger than the max, then we don't do anything. We just move on to the next thing. And then I'll do my print down here. So I'll say max, concatenate, max. I think that'll get angry with me if I try and do that. I think I've turned into a string. Yep, that's what I thought. And just needed to show you. Right, so it says something about can only concatenate string, not int. Like I said, in every other language I've ever used, it automatically converts a number to a string, because why wouldn't it? It says the max is 989. That seems believable. It's right there. That's weird that I got 989 twice. That's really strange that 9... Oh, anyways, it's not always the same. That's all I can tell you about that. I like these... Ooh, that's a good one. I like these random list problems because you and the person next to you are going to get different answers. So it makes you think for yourself a little bit more. All right, so just recapping. So here we did the whole... Here's how you make a random list of 100 things between 1 and 1,000. That was printing everything. This was finding how many things were greater than 50 and printing out that result. And this is what it looks like to find a max and print a max. What is the average value? This is the last one to do. So what's the average? So if you want to do an average, you got to get the sum of everything and then divide by the number of elements in the list. So we'll do yet another loop for this. You might be wondering, could we do this all in one loop? Yes. So if we're going to add up all the things in a list, it's like this. We're going to need... So this is an accumulator. This is a max. On this one, this is kind of like an accumulator. There's not a fancy word for it. I'm just going to call it sum, but it's like an accumulator. I'll initialize it to 0. And then I'll do a for loop. So for my value in numbers. Right? You see, I just keep calling it something different. Just to kind of make you understand that you can call this whatever you want. That you can't. That's got to be the list. And those keywords, well, those are what they are. So in this one, I'll just say sum plus equals my value. There's no if here. It doesn't have to be greater than 50. It doesn't have to be great. It's just everything. We're just going to go through everything, and we're going to keep adding it to the sum. And then at the end, we'll say print average is. We have to do a little math here. It's going to be stringify the sum divided by the len of numbers. You haven't seen me do len yet, but I told you that len is a thing that, oh my gosh, that seems like a lot of parentheses. Is that right? So that's len numbers. That's the stringify. I guess I didn't need that one. And so it's the stringify, and then that's the whole thing. Let's see how this works. So len numbers tells you how many things are in the list. Now, if the stuff is between 1 and 1,000, the average should be around 500. So that checks out. Ooh, it's pretty interesting how often it turns out to be pretty close to what you'd expect it to. Sometimes not so much. 513, that's the furthest that we've seen. 520. It should be somewhere around 500, and it is. Wow, that's a really low one. But anyways, you know, I'm weird. I like just running it and seeing how it goes. So that is like everything I could come up with that you might want to do to a list of random numbers. So we built the list, specified the range, specified the size of the list. This is what it looks like to print a list. This is what it looks like to use a straight up accumulator. So we're just looking at everything and seeing whether it meets a condition or not. And if it does, then we add one to the accumulator. And then at the end of the loop, we print the results. This is what a max looks like. So in a max, you always initialize the max to the first thing in the list. And then you work your way through the list, and you compare the current thing to the max. And if the current thing's greater than the max, then the max is now the current thing. If you didn't like the way that sounded, there's nothing I can do about it. That was the best way to say that. Trust me, I've taught a lot of people to do a lot of maxes and mins, and you pretty much can't explain it any differently than that. And then here, this is a straight up accumulator. So we initialize the accumulator as 0, go through everything in the list. There's no criteria, we just keep adding up the stuff in the list. And at the end, we print out the results. And the results are the sum divided by the length of the numbers. And I had to convert it into a string. That, converting it to a string is just a little punch in the gut that Python gives you over and over again. I mean, because the part that's interesting is the loop part, and the accumulator part, and the max part. But then you get this little stringify thing tacked onto the end. All right, so that is everything that I could come up with to do to a random list. So do spend time on that. Think about that. I'm going to have you do plenty more stuff with random lists before it's all said and done. And then from this point forward, we're going to start looking at lists full of like strings, as you'll see. Numeric stuff works pretty well. It's always more difficult to work with strings than numbers, and so the rest of this will be largely working with strings.